Number 4. Alright, now this one was a bit of a tricky one here. So we've got a local greenway indicated by the shaded region. It's bordered by 3 main roads. We've got Cross Street, Main Street, and Blake Avenue. And the city council wants to plant a wildflower garden. And it says the cost for the flowers is $5 per square foot. Alright, and so each little box represents 1 square foot. Every single one of those boxes is going to be $5 worth of flowers. So if this was a nice perfect shape like a rectangle or something, or we could count up all the boxes, that'd be great, because then we could count the boxes up pretty easily if we didn't know how to work through it mathematically, and then just multiply the number of boxes by 5. Alright? However, you see all these little half boxes and little pieces boxes, those are going to be pretty complicated to try and count. Alright, so that's why it's going to be nice to be able to figure out the area, how many boxes we're actually covering up here, some other way. Okay, now this triangle, if you look at it, if we were to be able to kind of turn this around, it almost looks like it is making a right triangle here. Right now, it is kind of hard to tell, and it doesn't tell us in the problem anywhere that it is a right triangle. Now, if it was a right triangle, we would be able to figure out the area by doing the base times the height, the 2 legs of the triangle, base times height, and then dividing that by 2, and that's the area. Then we could multiply the area by $5 per square foot, and that would give us the total cost. So we need to see if there's a way we can prove this is a right triangle. If it's not, then this problem gets really complicated, because then we've got to figure out the height of the triangle some other way. Now, we've not worked on that a whole lot, so you can usually assume, if it looks like it's a right triangle, that it is, if they don't give you the height some other way. Alright? So, but just to make sure we're on the right track here thinking about this problem, we are going to test this out and see if it in fact is a right triangle. So 2 ways we can do that. If I could prove that the slope of this line and the slope of this line are perpendicular to each other, that means it's a 90-degree angle in between them, and then that is going to prove that that is a right angle, so it is a right triangle. Or I could find the length of all 3 sides and try a squared plus b squared equals c squared, and if that works, the Pythagorean theorem works, then that means it is a right triangle as well. Right, so what I want to do first is look at the slopes, and then we may go back and test Pythagorean theorem to check if it's a right triangle that way. But let's look at the drawing here. Alright, I've not labeled everything, but I do just have a rough sketch of this. Alright, now my sketch isn't quite as accurate. Mine doesn't really look like a right angle here, but it's enough to help us figure out the lengths of the sides. So if I wanted to know the slope of this line right here, alright, I'm going to do this in blue, I just need to figure out how far over and how far down I'm coming on this line. So I'm at -5 in my x, alright, that's the x value here, and I'm at 0 in my y, or excuse me, 0 at my x here, so that means I'm going a distance of 5 over, and I'm coming from 4 down to -2, which is a distance of 6 coming down. So 5 over, 6 down. Now slope, if you remember, is rise over run. So I'll write this over here. Slope is rise over run, which is going to be -6, since we're going down, over 5. And you always measure going to the right. So we're going right 5, down 6. So rise over run is -6 over 5. Now when we look at this particular part, alright, we see that we are going up and then to the right. Now I'm just drawing a little box here, but we're going all the way up to this line, okay, from 0 all the way up here and then across. So let's think about how far we're going here. We are going up a distance of 10, so up 10, and over, right, so, and the reason I know we're going up 10, if you look at this y, -2 to +8, that's a distance of 10, okay, because it's 8 above, 2 below, add 8 plus 2, and that's 10. All right, then we're going across from an x of 0 to an x of 12, so we're going over 12. Now we're going up and over, so this is going to be a positive slope. The rise is 10, and the run is 12. So rise over run is 10 over 12. Now what does 10 over 12, that fraction, what common factor can I divide both of those numbers by? All right, I can divide them both by 2. If I do 10 divided by 2, that's 5. 12 divided by 2 is 6. So I can simplify that like so. Now look at these 2 slopes. This one over here, I'm going to circle it. is negative 6 over 5. This one is positive 5 over 6. Now if you remember from when we did an investigation on understanding the slopes of parallel and perpendicular lines, if you remember, parallel lines have the same slope, okay? Same slope for parallel lines, and that gets a little sloppy, excuse me, the pen's writing a little weird, but same slope for parallel lines. Perpendicular lines that meet at right angles have what we call, and I want to abbreviate this, opposite reciprocal slopes. And if you remember, opposite reciprocals means if one of the slopes is a over b, then the opposite reciprocal would be negative b over a. In other words, you flip the fraction and change the sign. So if it was positive, you make it negative. If it was negative, you make it positive. If you look here, we had a negative. Now this one's a positive, so that's where the opposite term comes in. And reciprocals, this was 6 over 5. This one's 5 over 6. If you can just show that the slopes are opposite reciprocals, that is enough to prove that this is a right angle. So now that I know this is a right angle, I know that if I do base times the height using the two legs of the triangle, and then divide that by 2, that's going to give me the area. Okay, so I already know, I'm going to actually draw the triangles on the outsides here instead of sort of connecting them from the inside. But let me come down here and just redraw these triangles on the outsides. Okay, instead of drawing them back to the inside to the y-axis. So I already know that this is a distance of 6 up and down, and this is a distance of 5. And then I know that across I'm going 12 on this triangle and up a distance of 10. So now we use Pythagorean Theorem. We do a squared plus b squared equals c squared. So 5 squared plus 6 squared will equal this distance squared. Alright? And we'll just call it c squared again for now. So 5 squared is 25. Hopefully you know that in your head. 6 squared is what? 36. Add those up and you should get c squared. So then we do 25 plus 36. If you add 25 and 36, you are going to get a total of 61. Alright. Again, you can use your calculator on a lot of this. I'm going to pull up a little application here to show our calculator. And then we'll go back to the drawing. We'll let this load up. So when you're working this out, give this just a second to load up. Remember, all you're doing is using Pythagorean Theorem to figure out the side lengths of each one of these. Alright, this is taking a little longer than I was hoping it would. There we go. Alright, so we did 5 squared and got 25. You can just see here on the screen. And then we did 6 squared and got 36. So if you didn't know those off the top of your head, just type them in. And then you add those numbers up. So a squared, which was 25, plus b squared, which was 36, gives us 61, which we saw. And then to figure out what just that length is, so we know c squared is 61, but that's not where we stop. We want to know the square root of that. All right? And be careful, remember, the square root of this term is not just 61 divided by 2. You take the square root to figure out what number times itself is 61, and that is not a perfect square, which means we're going to get a decimal here, and we get 7.8, which is pretty close to 8, all right, which makes sense because 8 squared is 64, which is a little more. All right, 61 is a little less than that, so 7.8 is a little less than 8. So 7.8 is going to be the distance of that side, so let me just minimize this. All right, so we have 7.8 as our distance. So that's this distance right here, 7.8. Then we do the same thing over here. 12 squared plus 10 squared equals this side squared. All right. Now, I do want to show you a little trick here. All right, we could do 12 squared plus 10 squared. All right, which we would give us 144 plus 100, which is 244. And then we would take the square root of that. Okay, so the square root of 244 gives us 15.6. Okay, so when I was doing that again, that was equal to this triangle's c squared. So if 244 was c squared, then we just saw that taking the square root of 244 will give us 15.6. So that's this distance right here. So now I have the base and the height of the triangle. But I told you I wanted to show you a little trick. If you notice, how does 6 compare to 12? Well, 6 times 2 is 12. How does 5 compare to 10? 5 times 2 is 10. And since both of these are right triangles, that means these are similar triangles. Okay? Which means that if I multiply this side by 2 and get 12, and this side by 2 and get 10, that's like the scale factor between these two triangles, which you may remember from middle school. So that means that I can apply the same scale factor, 7.8 times 2, and that actually would give me 15.6 as well. So I can do Pythagorean Theorem because it's not too complicated, but I also could have just doubled this side to get 15.6. Now, I want to go ahead and figure out the area now that I've got these sides. So let's do, to figure out the area of a triangle, remember, you do base times height divided by 2 for a triangle. So the base is 7.8, the height is 15.6. I'm going to multiply those and then divide that answer by 2, and that is going to be my area. So let's type this in on our calculator. 7.8 times 15.6 divided by 2. And that gives me an area of 60.84. 60.84. So let me minimize this. And let's write that area down. So we have a total area of 60.84 square feet. Remember, we were measuring this in feet. So that is how many little squares it would take to fill up the inside of that box. But if you look at the answer choices, one of the answers is $61. So someone is probably going to figure out, oh, the area is 60.8, that's really close to 61. There we go. There's our answer. But not quite. Remember the last thing that it mentioned. Every square foot costs $5 worth of flowers. So I need to take this number, 60.84, and I need to multiply that by $5. So 60.84 times $5 is going to give me a total of $304.20. 304.2 in money would be $304.20. So what is the minimum they should budget to purchase the flowers? It's clearly going to be D, since we need a little more than 304, so we might as well set aside $305. Okay, so our correct answer for this problem will be D. And if you missed any part of that or you were unsure, again, always leave comments, go back and watch the video again, and just see if hopefully this is enough to clarify how to work out question 4. So make sure you get to work for that, and then move on to the next.